In this example, we're going to compute an integral using integration by parts. However, we're going to have to use it more than once. So I'm going to show how to use repeated integration by parts using a shortcut, so we don't have to keep writing the integral over and over again. So we start off by doing the same thing as usual. So we choose u and we choose dv. So either we choose u to be x squared or u to be e to the 3x. In this case, we choose u to be x squared and dv to be e to the 3x. So the reason is because when we repeatedly apply integration by parts, we want this to eventually go to 0. So if you remember, for u, to get du, we differentiate. And starting from dv, to get v, we integrate. So the derivative of x squared would be 2x. And then the antiderivative of e to the 3x would be e to the 3x over 3. And then if we apply integration by parts once, then part of the integral is going to be the integral of u times dv, which would be 2x times e to the 3x over 3. But then because you have an x times e to the 3x, you're going to have to apply integration by parts again. So what's going to happen is you're going to have to choose u and choose dv again. But we already have u, so we can take 2x to be u, the new u, and then e to 3x over 3 to be the new dv, and just repeat this procedure again. So differentiating 2x would be 2. Integrating this part, you get e to the 3x over 9. And then you'll see that you have to compute the integral of this times this, but then we repeatedly apply again. Derivative of 2 is 0. Antiderivative of this would be e to the 3x over 27. And then we put it together using the alternating signs. So u times v would be this times this. The second u times v would be this times this, but then there's an extra minus sign. And then the next part would be this times this, it alternates to plus. And then finally, the last v du would be this times this, the minus sign. So let's put this together. So the first u times v would be this times this. The second u times v would be this times this, then minus sign. So minus 2x times e to the 3x over 9. The third u times v would be this times this. And then finally you have the integral of v du. Right, so then integral of v du would be, but 0 times this would be 0. So integral of 0 dx. But then that's just a constant. So then this is equal to 1/3 x squared minus 2/9 x plus 2/27. I can factor out e to the 3x, and then minus constant or plus the constant is the same. So this is the antiderivative. So we can just make a list like this, repeatedly differentiating u, and then repeatedly integrating dv, and then put together using the alternating signs to simplify the integration by parts.